I can talk with nothing on the page. I can do my math, and then I can talk over it. And the kids don't know that I just waited 10 minutes between these things to talk. I can record myself writing, or I can record myself after I'm done writing. Hi guys, I'm so sorry that I'm not posting this until the Wednesday of spring break. I've been super busy, my parents are in town, and I have a lovely cold. It's all fantastic. Anyway, my apologies. We're going to begin by graphing polar coordinates, remembering that the first number is the radius and the second number is the angle. Some people prefer to graph using the order in which the coordinates appear. So they go out to the fourth radius, the radius of 4, and then they go to the angle 2 pi over 3. I prefer to go over to the angle 2 pi over 3 and then count my radius 1, 2, 3, 4. Again, some people will go to the radius of 3 and then to the angle of 7 pi over 6, but I prefer to go over to the angle of 7 pi over 6 and count 1, 2, 3. I think I developed this habit because when you're looking at a negative radius, you need to go in the opposite direction along the angle. So, whoops, I highlighted the wrong angle, y'all. Give me a second. There we go. And instead of going 2 out, that would be wrong. You go 2 away, and that would be correct. Except my cursor is wanting to be a lasso. Okay. Last up, we look at negative pi over 6 to 2, and instead of going to pi over 6, we go to 11 pi over 6 and go out 2. And again, it wants to be a lasso. I don't really understand why it does that. Okay. In pre-cal, we learned the trig identities, which involve your radius, your x-coordinate, and your y-coordinate. These have been on your green sheet, and none of this should look new or surprising to you, but they become more useful as we go through polar here below. We convert to rectangular coordinates using the highlighted formulas above. Do your calculations, and voila, just like pre-cal. Convert to polar using the formulas highlighted above. And here's where you really need to know and understand your rules about arctan. Or I should say inverse trig. I suspect your memory may be a little bit fuzzy on the domain of arctan or any of your inverse sine functions. If you need me to go over that, I will. However, the fact that your arctangent only exists in quadrant 1 and quadrant 4 restricts theta to 7 pi over 4 or negative pi over 4. Once you have theta and your radius, you have your answers. These answers are all the same answer, the same point on your polar graph. So this is actually one answer, and I would not advise you give all 3 answers on any kind of free response. Just give one. This first one confuses the padiddle out of me. I just don't understand why you would want a line, a straight line in polar form. But I suppose we should practice just in case you end up in some engineering field where this is necessary. Y equals 4 looks incredibly convenient to me, simple. This r equals 4 cosecant theta looks cumbersome to me. But, you know, whatever. I don't know. I've never been an engineer, so for all we know, Emmett's going to use it every day for the rest of his life. Here's a circle. If you know your formula for a circle very well, you already know that your radius is 5. This is super easy to convert and much prettier in polar form. Doo-doo! On the lower half of this slide, we're going to convert our equations into rectangular form and sketch the graphs. It is easier to graph on a rectangular grid, than it is to graph on a polar graph. So, kind of understand why we might want to do this in real life. And there we have it, the line y equals 3, much easier to graph than the line r sine theta equals 3. This next one almost looks like x equals r cosine theta, but that doesn't quite make sense because the letter on the left side is r. So we're not going to work with that. We're going to try multiplying both sides by r. That will give us a form that we can work with. When we do that, we can see pretty quickly that we can convert r squared into x squared plus y squared, which pulls us into rectangular form. And we have ended up using x equals r cosine theta right there. From here, you should be able to see that you can just complete your square here. Once you've completed your square, you can see both your center and your radius. You have a circle with radius 1 with a center of 1, 0, and it becomes pretty simple to graph. Doo-doo! Hopefully your circle looks better than my oddly shaped football there. Here you have theta equals 2 pi over 3, so it's all the points along 2 pi over 3. So it's a line that looks like the line that I've drawn right there at an angle of 2 pi over 3. So we need to convert it, so we need it in terms of x and y. So if we want both x and y, we need to put it in terms of y and x. Tangent is the trig function that puts things in terms of y and x. So we're going to go ahead and solve for our line using that ratio. So we end up with a line y equals the negative square root of 3 over x. We have a line with a slope of negative square root of 3 and an intersection of, a y-intercept of 0, 0. Doo-doo! Now we're going to find the slope of the tangent line to a polar graph. And we can use what we know. All of these formulas you should be able to recall them fairly easily. I don't believe the two that are right in front of you right now. I don't believe those are on your formula sheet, but they also shouldn't look foreign. If you need them on your formula sheet to be able to remember them, I will put them there. But I don't think you do. I think you're going to be fine. To be clear here, this is not a brand spanking new rule to memorize. You should just remember that dy dx, wrong thing to write with, dy dx is dy d theta over dx d theta, and you should be able to remember this stuff and that you're applying product rule. This right here should not be difficult for you to create on your own on the AP exam. Memorize only what is necessary, honestly. Please do not memorize every single formula in the entire world. So when we go to an actual example, you should be able to use that formula, remembering that dy dx is actually dy d theta divided by dx d theta. Apply the product rule and figure out the derivative at the particular point. Once you've done your calculations for dy d theta divided by dx d theta, you can actually substitute 5 pi over 6 for theta, do your calculations, and you'll have your answer. Almost done. I'm just going to get rid of the 2's on the bottoms of both fractions to make this a little bit easier to simplify. I do that by multiplying both the top and the bottom by 2. And there we go. Doo-doo. Okay, you have a worksheet. You have actually 2 assignments over spring break, and they are both posted on Blend and on my website. I hope you all are having fun. I'm trying. Take care. Bye-bye.